This video shows how to simulate the response of a 612 mm long coplanar microstrip to a bit sequence previously calculated from the 100 picosecond step response to determine the maximum closure of the eye diagram at 5 gigabit per second bitrate. Here the coplanar microstrip cross-section data, coupon 40DR measurement, and DW cell extracted from the measurement are shown. The following bit sequence and worst case by contour have been obtained from the program DWV digital wave viewer starting from the response of the microstrip model to a 100 picosecond erfc step. 5 gigabit per second worst case by contour and worst case bit sequence calculated by DWV from the simulated step response. The following Spicy SWAN schematic is built up to compare the worst-case sequence and a PRBS sequence responses of the microstrip. Setting up the simulation parameters for the worst-case sequence response. Simulated signals for the worst-case sequence. Zooming on the isolated one signal to determine his amplitude. Switching to the pseudo-random bit sequence generator. Input-output signals for the 255-bit stimulus at 5 gigabit per second. The bit transitions are less critical than in the worst-case situation. Back to the worst-case bit sequence generator. Looking at the related eye diagrams coming from the digital wave viewer. Switching back to the worst case by contour previously calculated by DWV. In the following image, the eye openings yellow fields of the worst case by contour and of the actual simulated eye diagram are compared. The previous comparison shows the good match between the eye openings. This confirms the effectiveness of the worst-case eye diagram and related sequence for quick digital bandwidth assessment.